All right, hello, my name is Tate Niekamp, and this is Physics 2, Lab 3. I'm going to go ahead and hide this. So, for the introductions, the purpose of this lab was to understand the relationship between the distance and magnitude of a magnetic field from a barred magnet. We also wanted to learn how to visualize magnetic fields as well. And we wanted to compare measurements to the distance dependence predicted by on and off axis equations derived from the Biot-Savart law. So some of those physics principles. So we just mentioned the Biot-Savart law, where you see the equation there, and the distance dependence equations of magnetic fields. You can see those down below as well. So the main result of this lab was that the magnetic dipole was about 4.09, while the n value was about negative 2.6. We found that as the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases. Now, when this magnetometer is super far from the magnet, the x component is non-zero. That's only due to the Earth's magnetic field. So the experiment. So for the setup, I used a magnetometer app where I determined the magnetic north by rotating my phone until the x component became zero. I aligned this stick along the bottom of my phone, the meter stick, so that it ran east to west and orthogonal to the magnetic north with the magnet at the end. I located the magnetometer sensor in my phone by using tape, which found the position of where x and y components were at their max and min. I found the distance from the magnet to the sensors that produced a magnetic field with an x component of magnitudes 20, 70, 120, 170, 220 microteslas. Lastly, I found the distance d perpendicular, where the net magnetic field has a magnitude of 100 microteslas. At the bottom, you can kind of see some of some of the lab setup. So my assumption was that the x-axis was pointing along the width of my phone, the y-axis was pointing along the height of my phone, and the z-axis was pointing out of the screen. The magnitude of the magnetic field is proportional to a constant multiplied by a power of distance r. The initial orientation of my phone to find the magnetic north and Earth's magnetic field. And system was the magnetometer and the magnet, and the surroundings were Earth's magnetic field. So here's a little bit of the data. You can see the distances over on the left here. You can see the d perp and the magnetic fields below, and then the graph here. This graph is going to play in the next slide. So from the slope of the graph, the n was about negative 2.62, which is about negative 3. From the y-intercept of the graph, we could find that k was about 8.175 times 10 to the negative 7th. So using this formula here, we're able to find mu to be about 4.0756. So some sources of error were that there might be other magnetic fields and fields interfering, such as a computer, a laptop, phone, a bracelet. We could have accidentally bumped into the phone, and also just human error due to measurements with a meter stick. We didn't have a meter stick, so we used a ruler to measure out 100 centimeters on a piece of tape. So conclusion, let's jump into my glow script code. So here's my code. Here's where you see the magnitude of mu. And this was basically the Biot-Savart law. And down here where we set up the observations and the arrows. And so and here's the 45 degrees. So when we run this program, this is what it looks like. So you can see the arrows pointing in their respective directions, as well as the B at a 45 degree distance D up here. And that's what that comes out to be. Found the D is 0.239. And so now we were able to compare these. So let's go back to the presentation. So the experimental versus the computational was fairly close. You could see the magnetic fields being fairly similar, as well as the D being 0.239002 to 0.239002. So we were fairly close on our experimental and computational numbers here. So the lab questions. So if you haven't oriented your experiment to compensate for magnetic north and had instead laid out meter stick at some intermediate angle with respect to Earth's magnetic field, how would your results change? Okay, so my X results will have significant error as the Earth's magnetic field will skew the measurements of the barred magnet's magnetic field. This makes the calculated X values as well as the magnitude less accurate. So say you were to stick two identical magnets together end to end and run the experiment again, how would you expect your measurements to differ? So the two magnets would mimic a single larger magnet. So the direction of the fields are going to be the same, but the magnitude would be greater and multiplied by some scalar since these two magnets would come together to make that larger magnet. All right, thank you. That is my experiment.